Hello, my dear students. A warm welcome all of you once again here for Transient Analysis topic, okay? A warm welcome to all GATE aspirants, Engineering Service Exam aspirants, and PSU exam aspirants. Okay? A warm welcome to India's most comprehensive e-learning platform, that is BYJU'S Exam Prep. You have all sessions going to be here on network theory for the past 2 days, right? This is the third day we are doing. And in this session, I'm going to continue again with the transient analysis. Those who missed the previous sessions, don't worry. You will definitely follow, I can assure you, because I'm going to explain and emphasize wherever the concept is required. Today, we are going to spend time on the numericals. Okay, how to find the initial conditions, t equal to 0 plus conditions, okay, by taking some good number of numericals here, okay, which were asked in the previous GATE or ESE exams. We are going to take and we are going to discuss those things, okay. So if you have any doubts or anything wherever you do not understand, just put the doubt in the comment box. I will definitely clarify your doubts. Got it, okay? Well, for the newcomers, just an introduction I'm giving you here. That is, I'm Dr. Muneender Erukulla. You can see my name here. I did my master's and PhD both from NIT Warangal. I have 22 years of experience in teaching for GATE, ESE and PSU exam prep. My area of specializations, if you see, network theory, control systems, power systems engineering, okay, these three subjects have huge weightage in the GATE examination or ESE exam or even the PSU exams. Yes or no, okay? I presented research articles, some of my research articles in the International Conference of IEEE and IET, held at USA, Hong Kong, Malaysia, Korea and Singapore, okay? And also some research articles I published in the international journals as well. And I'm supervising 4 PhD scholars on the smart grid technology using artificial intelligence techniques, most advanced topic in the electrical engineering. I taught more than 250 batches across India for GATE, ESE, PSUs. And I guided, motivated, mentored 2 lakh plus students by visiting various engineering colleges, more than 500 engineering colleges across India. Okay, I directly met the students and visited and motivated so many students. Got it all of you, okay? So this is what a brief introduction about me. And please subscribe to the YouTube channel so that you will get the updates, because I'm going to take some important topics. I'm going to discuss some important topics of various subjects, not only network theory, but also the control systems, power systems, okay, along with the network theory. Okay, now you can also join my Telegram group. This is what my Telegram group, okay, Professor Muneender _ GATE EE and EC. Because if you join my Telegram group, you are going to get the material, the PDF of these YouTube lectures, and anytime you have a doubt, you can post and I can clarify your doubts, okay? And not only that, you will also get the updates. I'm going to share the links whenever I'm going to take the classes on the YouTube, okay? Whenever I'm going to take the classes on the YouTube for the subjects like, network theory, AC, steady state analysis in future I'm going to take. And the most important topics in the control system, that is stability analysis, okay, state space analysis, frequency response analysis, and also another important subjects, power systems. In that, the most important topics, high weightage topics, fault analysis, stability analysis, okay, power system stability, and then the load flow analysis. Okay, these are all very, very important topics that I'm going to discuss. Okay, yes, good evening, Ankit, how are you? Good evening. Good evening, all of you, okay? Very good, okay. Well, now, let's start our discussion. I think you remember, Ankit, you remember, I think yesterday you followed very well. I saw you answered the answers to the questions what we have discussed. I explained you the 3-step approach. The first step is to construct the t equal to 0 minus equivalent circuit and determine current through the inductor and voltage across the capacitor. Hi, Gupta. Hi. Hi, Sakshi Gupta. Okay. So now construct the t equal to 0 minus equivalent and find current through inductor and voltage across capacitor And if suppose you want literally the current through the inductor and voltage across the capacitor T equal to 0 plus, simply conclude that IL of 0 plus is equal to IL of 0 minus and VC of 0 plus is equal to VC of 0 minus. So this is what the procedure I explained. And go to step 2. In case if your objective is to determine, okay, other than current through inductor and voltage across capacitor, then you go for construction of the T equal to 0 plus equivalent circuit, right? Then third step, I told you that the initial conditions of derivative terms like di of 0 plus by dt, d square I of 0 plus by dt square, dv of 0 plus by dt, or d square v of 0 plus by dt square, something like that. Derivative terms, whenever you want, go for step 3, Nana. Obtain the linear differential equation for t greater than 0. That means after switching operation, because your interest is t equal to 0 plus conditions, okay? Then you obtain the linear differential equation by applying the KCL or KVL or the combination of both, okay? Combination of both, okay? And finally you get the differential equation in terms of the desired quantities, okay? Then you can proceed further. I explained you 4 problems, how to find I of 0 plus, d I of 0 plus by dt, d square I of 0 plus by dt square, and also v of 0 plus, dv of 0 plus by dt, d square v of 0 plus by dt square. For various problems have taken, 4 problems have taken RL series circuit, RC series circuit, RL parallel circuit, RC parallel circuit. Simple problems have taken to make you understand, right? So those who miss the classes, please go back and just watch the video. You will clearly understand. I'm telling you, if you watch the entire transient analysis, you know, okay, I'm sure that you become master in the transient analysis. I can give you an assurance, okay? If you have still, you know, get stuck any place, then please get back to me. I shared already my, you know, the Telegram group, okay? Or else you can keep the, you know, doubts in the chat box, then I'm going to clarify the doubts, okay? If not now, if suppose you don't get the doubts now, you are going to get the doubts whenever you're going through my video or whenever you're going through the textbooks, let us say, then please do not hesitate to interact with me. I always love to interact with the students and clarify the doubts. I feel very happy and honored. Understand all of you, okay? Well, now another important thing is that I'm going to give you a small update in this particular approach, because in the exam point of view, let us think now. This is a general approach, no doubt, okay? Always remember, okay, GATE is an exam which is always, based on the concepts. Understand all of you? People think that, you know, there are some shortcuts to get the rank. There are some shortcuts to get the, you know, very good score. But remember, I'm telling you here, the shortcuts are nothing but what your concepts only. If you're not thorough with the concepts, then that means that you do not know the shortcuts. You understand all of you? Don't expect the direct shortcuts are not available always. Your concepts, your fundamentals, okay, they are only going to be your shortcuts, I'm telling you. With those things, you are going to solve the problems. Got it all of you, okay? So here I told you a general procedure, 3-step approach, but I'm going to update in the exam point of view, keeping in mind most of the questions which were asked so far for the past 30 years. I'm suggesting you a 2-step approach, because in the exam, he is not asking beyond, okay, first order derivative terms, initial conditions of first order derivative terms. So look at this now, a simple 2-step approach, exam point of view I'm explaining here, okay? Then first step is what? Construct T equal to 0 minus equivalent and find current through inductor, voltage across capacitor, Nana. Then conclude that IL of 0 plus is equal to IL of 0 minus, VC of 0 plus is equal to VC of 0 minus, right? In case, okay, you want other than current through inductor, voltage across capacitor, and not only that, the first order derivative terms, look at this. What is this? dIL of 0 plus by dt. What is IL? Current through inductor. Okay, what is dVC of 0 plus by dt? What is VC on here? Voltage across the capacitor. In case, in the first order derivative term, like di of 0 plus by dt, where I is current through the inductor, and dV of 0 plus by dt, where V is the voltage across the capacitor, these two derivative terms can be determined from step 2 itself without going for step 3. There is no need to obtain the differential equation, and there is no need to waste your valuable time, because the competitive exams, you have to find some other alternative ways to solve the problem. Understand all of you, okay? So why actually we are going to, yes, good evening, okay, Ramesh, good evening. Now here, dIL of 0 plus by dt, dV of 0 plus by dt, how do we find it? Generally in the last session, I told you in the part 2, transient analysis part 2, please go back in case Those who are newcomers, please go back and you can watch after completion of this particular session. You can see, you can clearly understand in the part 2 session, I explained you that 3-step approach. Okay, third step is meant for what? To find the first order derivative terms, initial conditions of first order derivative terms. But I'm giving an exemption to two initial conditions of derivative terms, two derivative terms. One is di of 0 plus by dt, the other is dv of 0 plus by dt, where I is the current through the inductor and v is the voltage across the capacitor. You understand, all of you? Where v is the voltage across the capacitor. You can see that dIL of 0 plus by dt and dVc of 0 plus by dt. Now, understand? So why dIL of 0 plus by dt and dVc of 0 plus by dt are given exemption? Because you know that in case of inductor, this is L, this is IL, this is VL, let us say. So what is VL of t, Nana, here? L into dIL of t by dt. Yes or no? From this, we understand that VL of 0 plus, I am applying t equal to 0 plus to t equal to 0 plus conditions to this particular equation, Nana. Then what I get here is equal to L dIL of 0 plus by dt, Nana. Okay, from this we understand dIL of 0 plus by dt, okay, is equal to VL of 0 plus by L. Got it, all of you? Okay. So it is very clear. From this we understand the dIL of 0 plus by dt can be determined by finding simply what VL of 0 plus by, VL of 0 plus. But what is the procedure that we discussed to find voltage across the inductor at t equal to 0 plus, Nana? That is from step 2. Okay, that is from step 2. Look at this, construct t equal to 0 plus equivalent. Construct t equal to 0 plus equivalent for what? VL of 0 plus, IC of 0 plus, VR of 0 plus and IR of 0 plus. We have to construct t equal to 0 plus equivalent. Then we can directly get that value. There is no need to go for step 3 for that particular quantity. Understand, all of you? Okay. Similarly for capacitor also, you see for capacitor, okay, this is C and this is IC of t, Nana. This is VC of t. Okay. What is actually IC of t here? C dVc of t by dt, yes or no? So if you apply initial conditions to this t equal to 0 plus conditions to this particular equation, what do you get? Tell me. dVc of 0 plus by dt is nothing but IC of 0 plus by C. But tell me, what is the procedure to find this particular one? It can be determined, these two can be determined from step 2, that is nothing but constructing t equal to 0 plus equivalent. Then you can ask me again, sir, how to construct the t equal to 0 plus equivalent? Do you remember the procedure? I'm going to show you the newcomers who joined today. Don't worry, I'm going to again explain you how to construct the t equal to 0 plus equivalent. Understand, all of you? Okay, well. So shall we start a problem which was asked in the previous exam, that is GATE examination. This question was asked in the previous GATE, Nana. I'm not mentioning the year, you don't worry about the year here, but this question was asked in the previous GATE examination. Shall we read the question here, all of you? The rate of increase of voltage across capacitor. The rate of increase of voltage across capacitor. What do you mean by the rate of increase of voltage across capacitor, Nana? dVc of t by dt, yes or no? Okay. When the switch is closed at t equal to 0 will be, that means immediately after closing the switch. That means at t equal to 0 plus. That means he is asking dVc of 0 plus by dt, Nana. What is this? dVc of 0 plus by dt is asking. Okay. What is the formula for dVc of 0 plus by dt? Just now we have seen. What is that? dVc of 0 plus by dt is nothing but IC of 0 plus by C. Yes or no? Yes, Ankit. Very good. Okay. So what is this dVc of 0 plus by dt? dVc of 0 plus by dt is nothing but it is IC of 0 plus by C. That means I need to find IC of 0 plus. Tell me, what is the procedure to determine other than current through inductor voltage across capacitor t equal to 0 plus? Step 2 or not? Yes or no? Step 2 only, right? Step 2 means t equal to 0 plus equivalent circuit I have to construct. What is the procedure to construct t equal to 0 plus equivalent? Tell me. First we have to construct the t equal to 0 minus equivalent and find what is the current through the inductor and what is the voltage across the capacitor t equal to 0 minus. Based on the information available, that is current through the inductor at t equal to 0 minus, voltage across capacitor t equal to 0 minus, we can construct t equal to 0 plus equivalent. Look at this equivalent circuit, you remember? At t equal to 0 minus, first you construct the T, equivalent circuit and find what was the current flowing through the inductor, what was the voltage across the capacitor. Okay, so let me construct T equal to 0 minus equivalent. How it looks like, tell me, before switching operation, yes or no? Before switching operation, resistor remain resistor, inductor becomes short circuit, capacitor becomes open circuit. Then find the voltage across the open terminals, that is nothing but voltage across capacitor. Find current through the short circuit, nothing but the current through the inductor. And these values are corresponding to T equal to 0 minus, okay, quantities. Therefore, from based on that, you can, based on those values, you are going to construct the T equal to 0 plus equivalent. So how it looks like, if suppose voltage across the capacitor was found 0, then at T equal to 0 plus, it becomes short circuit. If suppose the voltage across the capacitor is found, let us say some V0, some constant value 10 volts, then it can be replaced by a V0, that is voltage source, with a series capacitor model. Okay. Similarly, inductor. But of course, in this particular problem, inductor is not there. But in case if inductor is there, if inductor current was 0, then it can be replaced by an open circuit. Okay. Somebody is actually texting. Let me just check. Yeah, I'm just going through it. If you have any doubts, please. Sri Ganesh, good evening, respect sir. I want to enroll for GATE online paid course for 22. Currently, I have just completed first year. Is there any batch available in October? So please visit the website. You will get all the information on. Okay, it is openly available. Don't worry about that. Ankit, initially switch is open condition. Yes, Ankit. Very good, very good. Ankit, you said the capacitor is short circuit. Very good. Good evening, all of you. Okay. Good evening, everybody. Ramesh, Sakshi Gupta, Christina. Good evening, good evening. Okay, fine. So let us now look at this. The problem here, we need to construct T equal to 0 minus none. First of all, step 1. Okay, step 1, T equal to 0 minus equivalent. Okay. Tell me then, T equal to 0 minus means what? Capacitor is acting like open circuit. Just now we have seen. T equal to 0 minus, the capacitor is acting like what? Open circuit. Switch is what? Open condition. Look at this. You are closing the switch at T equal to 0. That means T equal to 0 minus, it is an open condition. Then look at this. Yeah, this is what the capacitor, I'm highlighting the capacitor. So tell me, what is the voltage across the capacitor here? We would like to find Vc of 0 minus, based on which we can construct the T equal to 0 plus equivalent. Can you charge this capacitor by keeping an open circuit here? Is it possible? Never, right? So therefore, Vc of 0 minus is equal to 0. Now, based on this information, I construct here T equal to 0 plus equivalent. Step 2, construct T equal to 0 plus equivalent, Nana. How do you construct? When voltage across the capacitor was found to be 0 at T equal to 0 minus, then the capacitor becomes what? The short circuit, and the switch is now closed, right? Yes or no? So capacitor is becoming short circuit, resistor remain resistor, then switch is actually closed here, and here is an voltage source. As it is, we are going to place V is equal to 1 volt it was, right? Now, this is what the capacitor. Capacitor physically there, but acting like what? Short circuit, Nana. So what is the current flowing here? Tell me. IC of 0 plus, because whatever you find in this particular circuit, they're all corresponding to T equal to 0 plus. Agree all of you? Okay. Well, so what is this IC of 0 plus, Nana, here now? Is equal to, you can see that current flowing through the resistor is nothing but current flowing through the short circuit. Short circuit is nothing but what? The capacitor here, in this context, T equal to 0 plus condition, the capacitor is acting like a short circuit. Therefore, it is simply V by R, nothing but what? 1 by R. You understand? Okay. Then, what do you get? Tell me. dVc of 0 plus by dt is equal to IC of 0 plus by C. The simple formula is available. 1 by R by C, nothing but what? 1 by RC. This is your answer. A simple question, look at this. I'm able to find the first order derivative term, that is dV of 0 plus by dt, where V is the voltage across the capacitor. Look at this, okay, where V is the voltage across the capacitor. In the question, it clearly mentioned the rate of increase of the voltage across the capacitor when the switch is closed at T equal to 0, nothing but what? dVc of 0 plus by dt. Got it, okay? Well, now, shall we move on to another question here now? All of you followed? Ankit, are you okay with this? Very good, Ankit, very good. Well, coming to now, second question. Okay, it's also very simple problem. The circuits look, bigger, but don't worry, you can easily simplify them. Okay, I'm also going to take one important session in the upcoming classes. Okay, in the YouTube. Okay, how to solve the circuits using simple techniques, Nana. How to solve the circuits using the simple techniques. I'm going to actually take one important session on that. You understand? Okay. Yeah, this is the circuit actually you can see. Now tell me, what is asking? Determine I of 0 plus, V of 0 plus, di of 0 plus by dt, dv of 0 plus by dt, I of infinity, V of infinity. But just check, what is I of infinity? Yes, Mr. Roy, Sagar Roy, tell me. I'm just seeing your comment. What is that, Nana? Sagar, you're asking something. Yesterday I was a revision transient analysis. I'm not able to solve the problems, but concept clear. Okay, now you go through this particular session. That's why I'm taking, That's why I'm taking here. This session will help you, Sagar. Okay, this session will certainly help you, Sagar. You can just, follow these lectures because 6-7 problems I'm discussing in this particular session. Just follow step-by-step procedure, Sagar. I'm sure that you will understand. There is nothing difficult in this. But are you sure that you are expert in solving the circuit? I don't think you have any problem with circuit simplification. Node analysis, mesh analysis, KCL, KVL, current division, voltage division. You just play with the circuits, I'm telling you. Okay. Anyway, I'm going to take one important session how to solve the circuits. Here in this particular session, whatever the problems I'm taking, very simple problems only, don't worry. Okay. Some simple shortcut techniques I'm going to teach you in the upcoming sessions. I mean, not this particular duration. Till 18th, I'm confining myself to only the transient analysis, but I will take one more important session in the future very soon. Okay. How to solve the circuits in a simple manner. Just by looking at the circuit, immediately you must get an idea which method is the best method to solve the particular circuit given. I'm going to teach you that. Don't worry about that. Okay. Yeah. Good. So now here, let's try to understand here what is I of 0 plus, what is V of 0 plus. So Mr. Sagar, I think last class you attended, you said, okay. You tell me now, t equal to 0 plus condition, what is the procedure? First you have to see what is he asking. He's asking I and V. What is I? What is I? Is it current through inductor or other than current through inductor? You are supposed to answer like that. In this context, when I'm asking what is I means, okay, all of us know that it's current, but you can't answer like that. You must answer that whether it is current through inductor or current through other than inductor. Look at this. I is given clearly. It is current through the inductor. So I of 0 plus. Current through inductor may not change instantaneously. I of 0 plus is equal to I of 0 minus. That means in the first step itself, by constructing t equal to 0 minus equivalent, you are going to get the answer for this particular question. Similarly, V of 0 plus. What is V? My question is what? V. What is V, Nana? V is, okay, V is what voltage across the capacitor. Yes, I'm going to take, Nana. Siddiq, okay, I'm going to take power system also. Don't worry, I'll be taking. Okay, don't worry. Okay, nobody is master in the subject. Siddiq, okay, don't worry. You become master in networks. I'm telling you, networks is the backbone of every, electrical subject or electronic subject. I'm telling you, electrical, electronics, instrumentation. These subjects, purely based on the network theory only. If you are good at analysis of the network analysis, okay, then I'm sure that you are master in every analysis. Power systems, engineering, control systems, signal systems, analog circuits, digital, whatnot, everything you can. I mean, digital is not directly connected here, but analog circuits is directly connected here, okay? And especially electrical engineers, machines, measurements, power electronics, power systems, all subject base is here only, right? So better you concentrate on the networks, okay? And whatever the class I'm teaching here, the transient analysis, okay, you focus on this. In the future network theory class also you attend without skipping, I'm telling you, okay? Well, so I of 0 plus and V of 0. What is V, Nana, here? V is the voltage across the capacitor. What is the procedure to find voltage across the capacitor? Can anybody tell? Just by first step, that is t equal to 0 minus equivalent only, right? Because voltage across the capacitor may not change instantaneously. Vc of 0 plus is equal to Vc of 0 minus. Simply you're going to get the answer in the first step itself. Okay? So then look at this. How to construct the t equal to 0 plus equivalent? First you have to construct t equal to 0 minus equivalent. How do you construct T equal to 0 minus equivalent? Okay, Sagar, yeah. How do you construct T equal to 0 minus equivalent? Tell me. Resistor remain resistor because T equal to 0 minus and T equal to minus infinity both are same na. And inductor becomes short circuit and capacitor becomes what na? Open circuit. Yes or no? And before switching operation, 0 minus or minus infinity both are same na. Okay, but plus infinity and 0 plus are not same. Both are different. Understand? 0 minus minus infinity are same. Plus infinity is initial conditions, final conditions. 0 plus conditions are initial conditions. Both are different. But 0 minus minus infinity both are same. Okay, well. So shall we construct now T equal to 0 minus? So I told you already that my Telegram group, just please join this Telegram group, Professor Muneender _ GATE EE and EC. I told you that I'm going to take some classes. Okay, these particular upcoming sessions I'm going to take here. You can see on the screen, network theory, AC steady state analysis, and of course one more topic I would like to add that is simple, techniques to solve the circuits. And control system stability, state space analysis, frequency response analysis, and power systems, fault analysis, stability analysis, and load flow analysis. These are the important topics I'm going to take. Okay, please join this group, and I will also be sharing the PDFs of this particular lecture in the Telegram group itself. Okay, so what are the doubts you have? Anytime you can interact with me in the Telegram group. Okay, and I'm very happy to interact with all you guys. Don't worry about that. I'm there to help you. Okay, till your examination, don't worry about that. Okay, in BYJU'S, that is a trend that all faculty are very friendly and very helpful to all of you. Okay, so just try to follow their instructions. I'm sure that you will become successful, but ultimately you have to put the efforts. Don't think that there are no shortcuts to reach your goal. Okay, you have to put your efforts, but you need the direction. The direction will be will be given very effectively from the teachers of BYJU'S. Don't worry about that. Okay, but stay tuned always and be in touch and be sincere and honest in your preparation. Without that, you can't achieve anything. Okay, we may teach, we may put our efforts here, but ultimately you are supposed to follow and implement what are the strategies we explain you, right? Okay, well, now right now, yes, I'll go with don't worry about that. Right. Okay, so tell me now, T equal to 0 minus equivalent. What is T equal to 0 minus equivalent? Can you please tell me what is T equal to 0 minus equivalent? Step 1. What is the switch position? Siddiqui, tell me. Look at the switch position. It is closed at T equal to 0. Means at T equal to 0 minus, it is open condition. Yes or no? Okay. Sagar. Yes. Good. Very good. Look at this now. T equal to 0 minus. Yeah, you got 2.4. Okay. Let's see. Look at this. T equal to 0 minus. The switch is. Okay. But 2.4, please cross check once again. Ankit, what is the answer you got, Ankit? Switch is actually open condition. Very good. Capacitor is what? Open circuit. Resistor remain resistor. Inductor is acting like short circuit. I'm highlighting here by encircling. Those encircling, what is the circles? Tell me. Inductor and capacitors. Don't forget. Okay. Now source remains source here like this as it is. So this is 24 volts. This is short circuit inductor, that is, right? This is inductor, this is capacitor, this is 10 ohm, and this is 2 ohm. Now, look at this, what is asking here? I of 0 minus. And what about this? Plus minus, V of 0 minus, right? Voltage across capacitor, current through inductor. Tell me, here it is open circuit, therefore 10 ohm and 2 ohm, how they are connected, Nana? In series or not? Sagar, yes, 2 ampere. Very good, Sagar. I of 0 minus. This is what, silly mistakes happen generally, Sagar. You must be very careful. That will unnecessarily pull your confidence back. Though you are confident of your concepts, but the calculation mistakes will pull you back, I'm telling you. I always suggest the students that put your, pen and calculate it just by seeing the question and say, feel happy that, I got the answer. No, not like that. You must experience. Okay, you must experience, live experience must be there, putting your pen on the paper and calculate and get your own answer, then feel happy. Then only it is possible, I'm telling you. Otherwise, you know the concept, everybody knows the concept, but finally you answer it wrong. And GATE, that numerically answer type. If suppose 4 options are there, at least you have a possibility to pick the right option. In case if you get the wrong answer, you make an attempt again. But if you have a numerically answer type, fill in the blank, how can you understand whether your answer is right or not? There is no possibility to cross check your answer first of all. So be careful. Well, what is this? 2 amperes, right? What about V of 0 minus, Nana? V of 0 minus is voltage across the open terminals, nothing but voltage across the resistor or not? Agree all of you? So therefore, V of 0 minus is 2 into the same current is passing here 2, that is 4 volts. Now I can conclude that, okay, now I can conclude that I of 0 plus is equal to I of 0 minus is equal to, that is 2 ampere, okay, V of 0 plus is equal to V of 0 minus is equal to 4 volts. I think you all of you follow this. Okay, well, now if suppose only the first question is asked, then there ends the matter. Your answer is already obtained, no doubt. But suppose if second question is asked, di of 0 plus by dt, dv of 0 plus by dt. So what is the procedure to find di of 0 plus by dt, dv of 0 plus by dt? Nana? Step 2, construct t equals 0 plus equivalent. That is nothing but di of 0 plus by dt is equal to, okay, VL of 0 plus by L, yes or no? And dVc of 0 plus or dV of 0 plus by dt, where V is the voltage across capacitor, nothing but what? IC of 0 plus by C, Nana. IC of 0 plus by C. Got it all of you? So what is the procedure to find VL of 0 plus voltage across the inductor T equal to 0 plus, current through the capacitor T equal to 0 plus? You have to construct T equal to 0 plus equivalent. Shall we construct T equal to 0 plus equivalent here? Yes, let's try to construct here. Tell me, T equal to 0 plus, how it looks like, tell me. Resistor remain, you have to tell me now. Resistor remain, resistor, yes or no, okay. Inductor capacitor becomes what? It depends on what was the voltage across the capacitor T equal to 0 minus. What was that actually? Okay, 4 volts. Therefore, it becomes 4 volt source plus minus, and with a series capacitor model that generally we represent by the short circuit, but that is a capacitor. Okay, I'm highlighting that is a capacitor here, C. Then resistor remain resistor, but switch is now closed condition, yes or no? Now, inductor, okay, it becomes what? Current source. Look at the direction of the current that is flowing. Based on that, the current source direction will be there. Here, this is what the current direction. Therefore, I am placing the current source direction also accordingly, and with a parallel inductor model. This is what the inductor model, parallel inductor model. Okay, and then the source, whatever you have, as it is I am placing. If you are able to construct this T equal to 0 plus equivalent, if you are able to place, or if you are able to construct the T equal to 0 plus equivalent according to what I've explained here, then I'm sure that there is no confusion at all in the transient analysis, because the most important or the difficult part of this entire transient analysis as far as the numericals are concerned, constructing T equal to 0 plus equivalent only. And then how to simplify the network. See, how to simplify the network, if you don't know, I can't help you. Okay, so you have to put the effort there also. But first of all, you have to understand how to construct the T equal to 0 plus equivalent. Tell me here, what is this value, Nana? It is actually 10 ohm, right? This is 10 ohm. This is 2 ohm. And this is a capacitor. I need to find current flowing through the capacitor, right? Current flowing through the capacitor. That is IC of 0 plus. Current flowing through the short circuit is nothing but current flowing through the capacitor, because here the short circuit, what we have shown, that is a capacitor physically, but acting like a short circuit in series with the voltage source. Voltage source value is clearly found already. VC of 0 minus how much? 4 volts. Current source value how much? 2 amperes, right? And the voltage across, the inductor VL of 0 plus, nana, this is, the open terminals are there. And why I'm taking plus minus terminals? It is based upon the current direction. You know the passive convention. In the passive element, if you know the direction of the current, then you can indicate the polarities plus minus. If this is the passive element, you know the passive convention. If the direction of the current is known, these are the polarities. Current always flows from higher potential to lower potential. Okay? Or else if you know the polarities, you know the current direction. So therefore, I know that polarities of the voltage here. Based on that, I got the direction of the current downward. I know the current direction here. Based on that, I put the polarities here plus minus. Look at this, all of you. This is very important here. If you are able to construct T equal to 0 plus equivalent, there is nothing in this, I'm telling you. Okay? Well, now shall we calculate all the things what we require here? Since it is a short circuit, this is gone completely, because 10 ohm, you can't expect any current. That is short circuited already. Now tell me what do you want actually? VL of 0 plus. Voltage across the inductor. Voltage between two terminals, always we can calculate using KVL. Yes or no, all of you? Okay, always we calculate using KVL. Current through the any element, okay, voltage across two terminals can be calculated using KVL, current through any path, generally we calculate either by using Ohm's law or by using Kirchhoff's current law. So in whichever the path you're trying to find the current, Nana, in that first you verify whether you have any resistive element or not. If you have a resistive element, you can apply the Ohm's law, find current through resistor, nothing but current through that path. Okay, if you don't have a resistor in that path, then better you choose the Kirchhoff's current law. Understand all of you, okay? Well, so here in this path, it's very clear that there is no resistor. Let me choose the Kirchhoff's current law here. I applied Kirchhoff's current law either here or here. I'm choosing this particular point here. Okay, and I apply the KVL in this particular loop. Look at this. Okay, now for that KVL, I'm just putting a different name, that is nothing but touching concept. I start from the positive terminal and reach this negative terminal by certain way, like either clockwise or anti-clockwise, whatever it might be. So directly I can write here, I get here, if I follow VL of 0 plus is equal to, touching concept always says that when you're starting from positive terminal and reaching the negative terminal, whenever you come across the elements, make sure that the voltage across each element is known, and how you're touching the polarities you check. If you touch positive polarity first, look at this, you're touching positive polarity first, plus 24, and then you're touching negative polarity here. You're following like this. Look at this, you're following like this. Okay, and then you're touching negative polarity here, minus 4, nothing but what, Nana, 20 volts. Okay, Ankit, you got this value 20 volts, Nana? Siddiqui, Sagar, all of you, you got this 20 volts? The KVL you have to apply, Nana, to find the voltage. Now tell me, what is this IC of 0 plus? I told you already that you apply the Kirchhoff's current law, Nana. Here if you apply Kirchhoff's current law, then what happens here, tell me? The 2 amperes current is entering up to this point. Okay, to find current flowing through this path, you understand? Okay, you must know what is the current flowing through 2 ohm also. But what is the voltage across 2 ohm? 4 volts directly appearing, right? Then I can say 4 by 2 is nothing but 2 ampere. Now KCL says that 2 amperes is entering here. Yes or no? 2 amperes is entering and 2 amperes is leaving. Then what is the remaining current? 2 minus 2, 0 ampere. Sagar, yes. Ankit, Siddiqui, following. Very good, Nana. Very good. Okay. So I think you got the 20 volts and 0 amperes. Please respond. Okay. Then what do you get here? D I of 0 plus by dt, nothing but VL of 0 plus by L, nothing but VL, how much you got? 20 volts, 20 by, okay, then what is that inductor value? 0.4 Henry, 0.4 Henry, right? So what do you get, Nina? 200 by 4, nothing but 50. This is current, right? So ampere per second. Hope you follow this, all of you. Then what is dV of 0 plus by dt, Nana? It is nothing but IC of 0 plus by C. IC of 0 plus already 0, right? Therefore 0 volts per second. This is how you just simply solve the problems. Very easy to solve. I'm telling you, the transient analysis is very easy if you understand the T equal to 0 plus equivalent and every stage. That is very important. The table what I discussed earlier, that is very important. Okay, well. Now coming to the next problem. Very good. The current through this C, voltage across L at T equal to 0 plus will be. Options are given. This was the previous gate question, Anna. It was asked in previous gate examination. Look at this now. Current through inductor, voltage across capacitor. He's asking current through inductor or current through capacitor. Current through capacitor is asking. That means what? IC of 0 plus and VL of 0 plus is asking. So I told you already that other than current through inductor, voltage across capacitor, always remember, other than current through inductor, voltage across capacitor, always remember you have to construct T equal to 0 plus equivalent. In case if current through inductor or voltage across capacitor is asked, there is no need to construct T equal to 0 plus equivalent. Simply construct T equal to 0 minus and get the values of current through inductor and voltage across capacitor and then conclude there itself. IL of 0 plus is equal to IL of 0 minus, VC of 0 plus is equal to VC of 0 minus. But in this particular case, in this particular question which was asked in the previous gate examination, it was asked that find IC of 0 plus and VL of 0 plus. Then you have to construct T equal to 0 plus, right? But to find T equal to 0 plus conditions, you have to find first T equal to 0 minus conditions. Under T equal to 0 minus, what is your objective? Tell me. Respond all of you. Current through inductor, voltage across capacitor at T equal to 0 minus. Yes, Ankit, you got 50 volt. 50, what is that 50.0, Nana? Ankit, is that current through or voltage across? What is that? Tell me. Yes. So T equal to 0 minus, let us construct. How it looks like T equal to 0 minus? Resistor remain resistor, inductor becomes short circuit, capacitor becomes open circuit. Yes or no? So let's construct that. Okay. Well, T equal to 0 minus equivalent I'm constructing here. Tell me, how do you get it? Tell me here. T equal to 0 minus equivalent. Resistor remain resistor. I'm starting from here, okay? Resistor remain resistor. Right? But look at this. There is no source in the given circuit. Yes or no, all of you? There is no source. So even if you construct T equal to 0 minus equivalent and there is no source, how can you expect the current and voltage in the entire circuit? Tell me. When there is no excitation, how can you expect the current and voltage in the circuit? Tell me, all of you. You can't expect. But since inductor and capacitor are storage elements, okay, they can be charged initially, okay, they can be charged initially and they can be kept inside the circuit. They were already charged. I mean, charged inductor and charged capacitor. I'm just, you can see the circuit. I'm just giving you the place to observe the circuit. Look at that. Charged inductor and charged capacitor. Look at that. What is the charged inductor means what? No, how much current is shown here? You can see current flowing through the inductor was actually 10 amperes. That means it was charged earlier and kept inside the circuit. So is it not IL of 0 minus directly given? Yes, it is given. IL of 0 minus is directly given. How much, Nana? 10 amperes. There is no need to construct T equal to 0 minus because already the values are available here. What about VC of 0 minus? Tell me, it is given clearly. How much it was given? 10 volts, right? So therefore 10 volts here. So T equal to 0 minus step 1 is over. Already in the circuit itself they are provided. Now let us construct T equal to 0 plus equivalent. Now this is very crucial and important, Nana. Yes, Divya Kumaran, very good. Look at this 10 volts, huh? Okay, very good. T equal to 0 plus. Step 2, Nana. Can you construct T equal to 0 plus? Divya, tell me, T equal to 0 plus, how it looks like. This is very important, I told you that. In the entire transient analysis, construction of the T equal to 0 plus equivalent circuit is very important. So tell me now, what is that? Resistor remain resistor. Switching condition, at T equal to 0 plus, at T equal to 0 you are opening. That means it is open at T equal to 0 plus. Right? Tell me. What about the inductor? I told you already that inductor must be replaced by an equivalent current source in case if current through the inductor was, some non-zero value, 10 amperes, then equivalent current source with a parallel inductor model. The parallel inductor model, okay? This is nothing but VL of 0 plus. Got it, okay? Next. Here the switch is closed, Nana, because look at the switch direction, it is closed at T equal to 0. Then resistor remain resistor. Then tell me here, capacitor. Since voltage across the capacitor was found to be 10 volts at T equal to 0 minus, then it must be replaced by an equivalent voltage source with a series capacitor model. You understand, all of you? Okay. What is the voltage here, Nana? 10 volts, and this is what? 10 amperes. This is what? 10 ohm. This is what? 10 ohm. I hope you are understanding, all of you. All of you got the same thing here? Same equivalent circuit, all of you? Very good. Look at this. Divya, you got this, Nana? Short circuit. Divya, that's what I'm saying. Short circuit you cannot take, but here you must replace it by what, Nana? Voltage source in series with the capacitor model. T equal to 0 plus equivalent circuit, remember? Look at this. Inductor is replaced by a current source with a parallel inductor model, and voltage source must, capacitor must be replaced by voltage source with a series capacitor model. It all depends upon how much voltage was there in the capacitor at T equal to 0 minus, how much current was there at T equal to 0 minus in the inductor. Got it, okay? Well, so look at this now. The way you understood, Siddiqui. You didn't get, Siddiqui, where you got stuck, can you please tell me? Sagar Roy, okay, you are okay with that. Very good, very good. Siddiqui, you got? Divya, very good, Nana. Siddiqui, where you got stuck, tell me. I told you T equal to 0 plus equivalent when you are constructing. First you check how much current was flowing through the inductor at T equal to 0 minus. Okay? And you tell me how much voltage was there across the capacitor T equal to 0 minus. Look at this. Yes, I understand. That is T equal to 0 plus equivalent, you're not able to understand, right? Please respond quickly. Siddiqui. Yes. Tell me now here. So, what was the current flowing through the inductor at T equal to 0 minus? 10 amperes. Yes or no? What was the voltage across the capacitor at T equal to 0 minus? 10 volts. Direction. Yeah, why direction? Because look at the direction of current flowing through the inductor at T equal to 0 minus none, upward. Then upward should be placed. At T equal to 0 minus, what was the current direction that you have to see, and then you accordingly you have to proceed, Nana. Yes, Siddiqui, 10. Very good. So, based on that, we are supposed to construct. Just go back to the circuit table here. What is the equivalent of the inductor at T equal to 0 plus? It is based upon what? What was the current flowing through the inductor and capacitor, right? What was the current flowing through the inductor and what was the voltage across the capacitor? Look at this. Current flowing through the inductor was I naught, then it is the equivalent circuit, a current source with a parallel inductor model. Look at this. The voltage across the capacitor was found to be some 10 volts, then it is equivalent to voltage source with a series capacitor model. You understand now? Okay, that's what I am doing here. The voltage across the capacitor was 10 volts, that is why I placed 10 volts with the in series capacitor model. Then inductor current was found to be 10 amperes, then I am replacing that inductor by a current source with a parallel inductor model. Now, is it okay, Siddiqui? Got it, very good, Nana, very good. Now, how do you solve it? It's very clear there are two sources, some resistive elements. You want to solve this, then probably the node analysis is the best option to solve this network. But ultimate objective is what here? You want to find current through capacitor because that is a question. Look at this. What is the question? Current through capacitor. I mean, this is IC of 0 plus and VL of 0 plus. Tell me where is VL? This is VL and this is C, right? What is IC? Can I say this is what IC of 0 plus, Nana? Can you please respond? IC of 0 plus. Okay, this is what IC of 0 plus. This is what IC of 0 plus. I told you already that first you solve using the node analysis. Look at this. This is what V of 0 plus. Some voltage. One node voltage is enough here because it's very clear. Now tell me how do you solve it. Okay. Can I tell that V of 0 plus by 10 and then minus 10 amperes. V of 0 plus minus 10 by 10. All of you agree with this? Okay. V of 0 plus by 10 minus 10 amperes plus V of 0 plus minus 10 by 10. You agree all of you? This is equal to 0. If you apply inspection technique, generally I use this inspection technique just by seeing the circuit, you have to write the equation, that's it. You should not take much time, I'm telling you. I always suggest the students to follow the inspection technique, okay? So what is that inspection technique? Just see how many passive elements are there connected at this particular node. 10 and 10, 1 by 10 and 1 by 10 you directly take, okay? So 1 by 10 plus 1 by 10, that's it. Is equal to, if the current is entering here, outside you are taking, then you take plus 10 amperes. Then you see whether any source is there in the particular branch. Look at this, in this particular branch there is a source. Just see how you are touching the polarity here. Positive polarity you are touching. Therefore, plus 10 by the series resistance value you are supposed to take, okay, 10. See, if you rearrange this equation, you will be getting this, right? But without writing this, you are supposed to write this. That is what I am trying to explain you. Then only you can call it an inspection. Otherwise, it is not inspection. Okay? Tell me now, what do you get? Anyway, if you have any confusion with this, then follow this way. Don't worry about that now. Now tell me here. 2 by 10 Nana is equal to 10 plus 1, that is 11, right? This is 5. Then V of 0 plus is equal to 55 volts. Okay? So V of 0 plus is equal to 55 volts. But VL of 0 plus, what will you get, Nana? Because of the polarities minus plus. Okay? But V of 0 plus polarities are plus minus. Node voltage is at higher potential, right? But how you are measuring the VL of 0 plus with reverse polarities, then what do you get, Nana? Then you get VL of 0 plus is equal to minus 55 volts. You understand all of you? Okay, minus 55 volts. Okay. Then what about IC of 0 plus? Look at this current. Current through any path. What is the procedure? If there is a resistive element in the path, then apply the Ohm's law. Tell me, there is a resistor or not? Yes, you have a resistor. Then what is the current flowing through that resistor? V of 0 plus minus 10 by 10. I hope you all agree. Okay, V of 0 plus minus 10 by 10 is nothing but IC of 0 plus, Nana. Therefore, IC of 0 plus is equal to 55 minus 10, 55 minus 10 by 10, nothing but 45 by 10, nothing but 4.5 amperes. You got it? Very good. Divya, you got 55. Siddiqui, you got 5 volts, Nana. How you got 5 volts? Look at this. V of 0 plus, you get 55 volts. Okay? Well, so 4.5 amperes you got. So just check the values here. What are the options given? Look at this. 55 volts and 4 amperes. Current through capacitor 4 amperes, and this is given. It is supposed to be minus 55, but sometimes he give plus 55 because he did not ask the voltage across the inductor with some particular polarities. He is just connecting a voltmeter across the inductor either like this or like this. That means with plus minus polarities or minus plus polarities, we do not know. Okay? Whenever the voltage is asked without any polarities, that means he is expecting just a magnitude. Even if you have negative sign, just ignore it. Okay? In the options, that is why I am choosing option D. This was asked in the GATE examination for 2 marks, Nana. Okay? So I hope you understand this. Very good, Ankit. Very good. You got 4.5. Divya, you got 4.5. Very good. Very good. Initially, you got 6.5. Divya, somewhere you did the mistake, I think. Okay? Good, good. Very good. Now, shall we proceed with the other problems? I told you already that. Please join this group. I will be definitely giving you some assignments also this time, network theory. Okay? And you please keep posting your doubts and questions. I'll be trying to answer those questions. Okay? So I'll be in the process of clarifying your doubts also. The teacher always, gain a lot of knowledge. Don't forget that. In my 22 years of experience, okay, we gain this experience, we gain this knowledge only because of what? By clarifying the doubts of every student. Yes or no, all of you? We go through different varieties of textbooks and we come across different varieties of students, different varieties of questions, okay? That's how we generally build the knowledge, okay? So there is nobody is master in any subject, okay? It's a continuous process, it's a continuous learning process. We have to put our efforts continuously to learn the things, okay? Well, now let's go to another question which was asked in previous GATE examination, okay? Again, this was also previous GATE question, Anna. I'm trying to take the GATE questions for a reason that you get clear idea that how GATE questions are coming, okay? So I just keep aside here myself, just see the question. He's asking Vx of 0 plus, Nana. What is Vx of 0 plus? Voltage across the resistor at t equal to 0 plus. What is the procedure to find voltage across the resistor at t equal to 0 plus? Any quantity that is other than current through inductor, voltage across capacitor t equal to 0 plus, if you want to find, you have to construct t equal to 0 plus equivalent. Most of the questions in the GATE, if you observe, okay, they are asked based on the construction of t equal to 0 plus equivalent. Very rarely based on the t equal to 0 minus equivalent, you will get the direct answer. But generally, most of the questions are asked based upon the t equal to 0 plus equivalent, Nana. Okay, so let's do that now. Quickly, I think we have 2 more problems. Let me proceed further here. Okay, well, tell me now. But to construct t equal to 0 plus equivalent, we have to proceed with t equal to 0 minus equivalent. How do you construct t equal to 0 minus equivalent? Can you please tell me? Resistor remain resistor, inductor short circuit, capacitor open circuit. Switching operation not happened, okay, before switching operation. Based on the information that is current through inductor and voltage across capacitor, okay, then we'll decide what is going to be the t equal to 0 plus equivalent. Tell me then. Tell me here. T equal to 0 minus equivalent. Okay. Initially, what happened here? Switching position. Look at the switching. Opened at t equal to 0. That means t equal to 0 minus. Is it closed condition or open condition, Nana? Okay, closed condition. Switch is closed. You agree, all of you? Very good. So, how do you get it now? Resistor remain resistor. Current source. What happens to the current source, Nana? Tell me. 2.5 ampere. And this is 20 ohm. And tell me here what happens here? Yes. The inductor becomes what? Short circuit. Agree, all of you? There is no capacitor here. I'm highlighting the inductor once again here. Okay, I'm highlighting the inductor. Resistor remain resistor. This is 20 ohm. Okay, our objective always in the t equal to 0 minus equivalent is to find current through the inductor. Very good, Arvind. Arvind, you got minus 50 volts. Okay, let's cross check that answer. Okay, well, let me see other people also how they are going to answer it. Okay, let me give you the answer at the end of this particular discussion. But I appreciate giving the answer. Just cross check once again. Well, 2.5 amperes, that's current source, 20 ohm, and this is 20 ohm. Look at this now. What is your objective in this? Current flowing through the inductor, nothing but current through the short circuit. Tell me what is the current flowing here? This current can you expect here because it is a short circuit completely. Okay, you can't expect any current here, you can't expect any current here. Entire current is flowing through what? The inductor, that is nothing but 2.5 ampere. That means IL of 0 minus is 2.5 ampere. My objective in t equal to 0 minus is always to find, okay, current flowing through the inductor at t equal to 0 minus. That is 2.5 ampere, okay, 2.5 ampere. Let me now construct based on this information t equal to 0 plus equivalent, Nana. What is that? Resistor remain resistor. Okay, current source remain current source. Switching is open now, right? Look at the direction of the switch. Opened at t equals 0. Then what about the inductor? I told you that it depends upon current flowing through the inductor at t equals 0 minus. Siddiqui, Ankit, Divya, Sagar. Hope you understand the current source now. It is current source with a parallel inductor model. This is an inductor. Resistor remain resistor. Right? This is what? Actually 20 ohm. This is 2.5 ampere. Okay? This entire current is passing through this resistor in this direction, that is 2.5 ampere. Because of this direction of current, you will be getting the polarities plus minus, because passive convention you know very well. But how this voltage is measured with the reverse polarities? Look at this. With reverse polarities it is measured. Yes or no? Okay? With reverse polarities is measured. Therefore, it is asked minus plus polarities Vx of 0 plus. It is exactly opposite to the actual polarities. Desired polarities are opposite to the actual polarities. Actual polarities are based on the direction of the current flowing through the resistor. Desired polarities are how you are measuring with the help of your voltmeter. That's it. Desired polarities you can call it. So tell me now, what is Vx of 0 plus? Because there is a mismatch between the desired polarities and actual polarities, I simply put minus sign here. 2.5 into 20 here. Okay, what do you get, Nana? Minus 50 volts. Okay, Divya. What is parallel, Divya? Okay. Arvind, great, you got minus 50 volts. Ankit, all of you got? Ankit, you got 4.5. Yeah, that's the previous question, I guess. Okay. Arvind, minus 50 volts, correct, Nana. Divya, what happened? That parallel combination, Nana. Where is the parallel combination? You're talking about the resistors. Yes, of course, all are connected in parallel, Nana, no doubt. But there is a short circuit, yes or no? Okay, I can connect it. Very good. That idea is good. Look at this. This is what the resistor. This is what current source. And this is what the short circuit again. And this is what the resistor. Look at this. This entire short circuit only, right? Yes or no? Okay. Here is a short circuit. Here is a short circuit. But entire current is passing through what? The inductor only. Yes or no? Yes or no? Because it is not flowing any current. Entire current is passing through the short circuit. Arvind, very good. Okay. Hope you understand, Divya. Is it clear? You got that answer? Minus 50 volts, Divya. Okay. Well, now another question which was asked in the GATE examination. Okay, Arvind, I'm expecting the answer from you again here. Other people also. Ankit, Divya, Sagar. Just please quickly respond. Even Siddiqui also. You can try. There is nothing wrong even if you do mistakes. Okay, learn from the mistakes. Nothing to worry about that. Okay. Don't get tense unnecessarily. You need a lot of patience when you're trying to learn the subject, I'm telling you. These are all engineering subjects. Okay, these are all engineering subjects. Okay, you need to have patience to learn the things, that's it. The basic requirement and the one and only requirement is the patience. Understand all of you? Okay, well. Coming to now, here. Let's try to understand current flowing through the 2C at t equal to 0 plus. Current through 2C means capacitor. This is what the capacitor, its value is 2C. It's just asking what is the current flowing through the capacitor at t equal to 0 plus. Again, current through capacitor t equal to 0 plus, certainly you have to construct t equal to 0 plus equivalent. Okay, suppose if he's asking what is the current flowing through inductor, then you will get a t equal to 0 minus itself, yes or no? IL of 0 minus if you find, then IL of 0 plus you will get it. But he's asking current through capacitor, you have to go for step 2, that is t equal to 0 plus equivalent. Okay, so let's construct now. Before that, t equal to 0 minus equivalent. Can you tell me what is t equal to 0 minus equivalent? T equal to 0 minus equivalent, step 1 first. Because if you want to construct t equal to 0 plus, first you have to construct t equal to 0 minus and find what was the current flowing through the inductor. What was the voltage across the capacitor? Based on that, you can construct T equal to 0 plus equivalent. Agree all of you? Well, Siddiqui, you got, okay. Divya, very good. Chaitu, hi Chaitu. Okay, joined bit late, I think, Chaitu. Okay, go through the video, you will understand clearly, okay? Don't worry. T equal to 0 minus equivalent, can you please tell me? Source, voltage source, resistor remain resistor, resistor again remain resistor, inductor is acting like short circuit, okay? What about the switch, Nana, open or close? You are closing at T equal to 0, that means T equal to 0 minus it is open condition. What about the capacitor, Nana? Capacitor is acting like open circuit. DC excitation, na? Always under steady state condition. T equal to 0 minus or minus infinity, both are same. Open circuit, I am trying to highlight the capacitors here. One is 2C, the other is C. This is an inductor L. Okay, this is 4 ohm, this is 2 ohm, and this is 18 volt. Got it, okay? Then tell me here, what is your objective in this? I would like to find current flowing through the inductor, voltage across the capacitor, and T equal to 0 minus. Tell me, what is the current flowing through the inductor? Can you expect, because these two are open condition, 2C and C, open conditions, can't expect any current in this particular one, right? Can you expect current here? No. So entire current is passing like this. Yes or no, all of you? Can you please tell me now, what is that current, Nana? IL of 0 minus. Tell me, IL of 0 minus. Any answer? Yes. Rams, what is your correct name? Tell me. Rams King is there, okay? What is your correct name, Nana? Okay. Tell me here. 18 by 2 plus 4, that is 3 amperes. Very good, Rams, okay? But is it 2 amperes or 3 amperes? Tell me. 18 by 6, Nana, here. Because it is 18 volts. This is 2 plus 4, 6. That is 3 amperes or 2 amperes? Tell me. 3 amperes. Divya, very good, Nana. 3 amperes. Very good. Okay, what about voltage across 2C and voltage across C, Nana? Voltage across 2C of 0 plus. Voltage across C, that is 0 plus. Tell me, Nana. Okay, how do you find that? Physically, there are two capacitors. How they are connected? Because these two, this is an open circuit. How these 2C and C are connected? Can anybody answer? How 2C and C are connected? Can anybody answer? Very good, Ankit, you got 3 amperes, very good. I'm asking you a simple question that how 2C and C are connected, Nana. Okay, they are not simply open circuits, remember, they're acting like open circuit, but physically there are two capacitors which are charged completely. Tell me, how they are connected? They're connected parallel, Ankit, or series, tell me. Entire current here, because it is open circuit, okay, because it is open circuit here, can you expect any current in this open circuit? No, but, okay, here, if you have because physically capacitors are there, entire current is passing like this, they are connected in series. Very good, Arvind. Very good, Vinay. Yes, they are connected in series, Nana. Divya, series combination. Very good. Two capacitors are connected in series. If you know the voltage across the combination of these two, because they're steady state condition, right? They're already charged to full voltage, right? What was that voltage? Can you tell me? That voltage across these 2 points. Across these 2 points means, across these 2 points, here it is short circuit, it's nothing but voltage across 4 ohm. You agree, all of you? So voltage across 4 ohm is nothing but voltage between these 2 terminals. You agree, all of you? Okay, yes or no? Voltage between these 2 terminals, voltage between these 2 terminals is nothing but voltage across 4 ohm. All of you agree? Divya, Vinay, Arvind, Rams, Ankit, all of you. Sagar, please respond. Are you going to tell me here that voltage across the 2 terminals I have marked with a red pen? Look at this, red ink. Okay, the 2 terminals here, AB, let us say. Is it not voltage across the 4 ohm, Nana? Agree, all of you? Yes or no? Arvind, very good. Ankit, very good. Look at this now. What is this voltage across 4 ohm, Nana? Already you know current flowing through this 4 ohm. The current flowing through short circuit or inductor is current flowing through 4 ohm. How much it is? 3 into 4, then 12 volts. That means voltage across AB terminals is how much now? 12 volts. Now this 12 volts, you are supposed to divide among the 2 capacitors. That is nothing but V2C of 0 plus. Opposite capacitance how much? C by C plus 2C into how much voltage here? 12 volts, right? 12 volts. Tell me here now, how much you are going to get? C by 3C. CC get cancelled. How much it is? 4 volts. What is the remaining voltage? VC of 0 plus 18 minus 4. Nothing but what? 18 or 12? 12 minus. Sorry, it's not 18, it's 12. Okay? 12 minus 4. Nothing but 8 volts. Look at this. All of you understood this now, Ankit? Everybody should respond. Divya, yes, very good, Nana. 4 volts and this is 8 volts. Now you got current through inductor, voltage across each capacitor. Can you construct T equal to 0 plus equivalent or not? Divya, 14 how, Nana? How 14 you got, Nana? Divya, 4 volts is okay, but it's not 12 minus 4, na? Yeah, very good, Divya. Okay, very good. Can we construct now T equal to 0 plus? Please respond. Yes, T equal to 0 plus. Can you please tell me how it looks like? 18 volts. 18 volts. I'm constructing now T equal to 0 plus. 18 volts. This is 2 ohm. This is 4 ohm. And this is current source. Here you understand how to solve the circuits. If you don't have command on the circuit solving, okay, it's very difficult. Now the first step is make sure that you are very good in solving the circuits. The capacitor is replaced. The inductor is replaced by what? A current source with a parallel inductor model. What was the current flowing earlier you have seen? Tell me. 3 amperes. I'm putting here 3 amperes. Look at this 3 amperes. This is an inductor. Parallel inductor model, right? Here, 2 capacitors are placed by voltage sources with a series capacitor model always. Okay. Now, this is 2C. Already you know that. This is C. This is 4 volts. This is 8 volts. Now the question is, what is the current flowing through 2C? This is what actually required. You understand? What is the actual question actually given in the problem? Tell me, all of you. He's asking current flowing through 2C, Nana. Now tell me, how do you find this? Now tell me, how do you find this? Tell me, how do you find this? Okay. It's very clear. The circuit is very clear. This is actually 18 volts, right? Yes. Current flowing through 2C, nothing but what? Current through voltage source. There is no resistive element in the path. Whenever you remember, whenever the current is asked in the path where the resistive element is not available, usually you solve it using Kirchhoff's current law. Understand, okay? KCL is the only option. You apply the KCL at this node or at this node, but I prefer this node, node A. Node A I'm preferring. If you want to apply KCL at node A, Nana, you must know current flowing here in the 2 ampere. You must know current flowing here, that is 2 ohm and 4 ohm current must be known here. If you don't know current flowing through 2 ohm, if you don't know current flowing through the 4 ohm, you cannot find what is I2C because there are 3 branches connected in this node. Tell me now, what is actually the current flowing through 2 ohm? You can't put 18 by 2 because you must know what is the voltage at this point. You already know this is 4 volts, this is 8 volts. What is the total voltage available here? 12 volts, right? So therefore I can say that this particular node voltage is 12 volts. Okay, then the current flowing through 2 ohm is, 18 minus 12 by 2, nothing but what? 6 by 2, nothing but 3 ampere. You understand, okay? Then what is the current flowing through 4 ohm, Nana? Current flowing through 4 ohm is, here the voltage directly, this voltage is appearing across this, 4 volts, that is nothing but 4 by 4, this is 1 ampere. You understand? Arvind got 2 amperes. Arvind Reddy, node voltage 12 volts, very good, Nana. Very good, very good, very good. So current flowing through 4 ohm is how much now? 4 by 4, 1 ampere. That means here it is 1 ampere. Here it is how much, Nana? 3 ampere. Then apply the KCL. Current through 2C, that is 0 plus, is nothing but 3 amperes entering, 1 ampere is leaving. The remaining amperes is flowing through the capacitor 2C, that is nothing but 2 amperes. Very good, Arvind. Excellent. Ankit, you got 1 ampere, just check once. Yeah, what is that 1 ampere? Yes, current flowing through 4 ohm is 1 ampere. But current flowing through 2 ohm is what? 3 ampere. Then finally when you apply KCL, what is actually current flowing through 2C, Nana? That is I2C of 0 plus, that is 2 ampere. Divya, you got 2 ampere. Very good, I appreciate you, okay? Very good, very good, very good. Okay, following this, all of you. So this question was asked in the previous gate. Okay, very interesting, right? So this level of questions we can expect always. Understand, all of you? This level of questions we can expect. So this problem I'm giving you for homework. This is very interesting question. All of you can note down. I'm giving you homework. I'm just giving you this. Look at this problem. I'm giving you this homework. Solve I of 0 plus, V of 0 plus, d I of 0 plus by dt, dv of 0 plus by dt, I 5 of 0 plus, that means current flowing through 5 ohm at t equal to 0 plus is asking. And look at this, no switching operation is mentioned. Instead, he has given 40 u of minus t and 40 u of t nana. You understand, okay? You must solve it. Tomorrow's class, we are going to discuss this particular question. And I feel very happy if you can come up with a solution. And put this solution in the comment box itself after solving in the comments, okay? If you put it, I'll verify it. Arvind, Sagar, Divya, Ankit, okay, actively participating, okay? So till 18th, I'm going to discuss some special questions also, special problems in transient analysis. Nobody generally discuss those questions, but I'm going to discuss those special problems in the transient analysis. I'm sure that you will enjoy. Based on the questions which were asked in the previous gate only, I'm going to discuss some special problems in the transient analysis. Okay, so stay tuned till the end, that is 18th I'm going to take. Okay, same timings. Only on 18th I'm not taking 6 p.m. but till 17th I'm going to take till 6 p.m. Nana. Okay, very good, Arvind. Good. Okay, so I told you don't forget to join the group, that Telegram, because I just want to interact with all you guys, and I keep sending some assignments and some homeworks, or let's have doubt discussions in that particular Telegram channel, okay? And this is a group you can join, okay? And I'm going to give you the updates of the future upcoming classes on control systems, network theory, and power systems. I'll take most important topic, high weightage topics, okay? And I'll discuss. And for that, I'll be giving you the notifications, or I'm going to send the links, okay, to join the classes whenever it is going to happen. Whether it's a free app classes or YouTube classes, I'm going to give you that, okay? So thank you so much for your patient listening, and wish you all the best, okay? And let's meet tomorrow. Have a great day, all of you. Thank you. Bye-bye. Take care.